Hello everyone. Today we're going to be doing a nice radical equation, namely 2x squared plus 3x minus 5 times the square root of 2x squared plus 3x plus 9 is equal to negative 3. So I'm going to start by adding 9 to both sides, and what that will give me is 2x squared plus 3x plus 9 minus 5 times the square root of 2x squared plus 3x plus 9 is equal to 6. 9 minus 3, which is 6. Now notice that this quantity here and this quantity here under the root are the same. Okay? So what I'm going to do now is simply use a t substitution. So I'm going to say that the square root of 2x squared plus 3x plus 9 is equal to t. Now when we square both sides, we will get that 2x squared plus 3x plus 9 is equal to t squared. Now, with that in mind, let's plug in these values into this equation right here. So instead of the first part, which is this one here, I'm going to put in t squared minus 5 times, since this here is just t, I'll just write it down as such, minus 5 times t is equal to 6. Or in other words, t squared minus 5t minus 6 is equal to 0. Now, we've got a quadratic equation in terms of t right here, and you could use the quadratic formula to solve this, but I'm going to use a slightly different approach. I'm going to rewrite minus 5t as something else. I'm going to rewrite it as minus 6t plus t, minus 6t plus t, and I'm just going to rewrite minus 6. Now I'm going to pull out the t from the first two factors in front of the parentheses, and I'm going to get t minus 6, and I'm going to also pull out the 1 from the other two factors, which will give me that t plus 1 times t minus 6 is equal to 0. Now, in both of these cases, we've got two possible cases. Either t plus 1 is equal to 0, which would imply that t is equal to negative 1, or, in other words, since t is this square root right here, the square root of 2x squared plus 3x plus 9 is equal to negative 1. Now, What we usually like to do is that we like to assume the principal root, the so-called principal root, which is a positive value. So this here, it can be solved by squaring both sides, but I don't think that will give us a nice solution in any way. Just for the fun of it, I'm going to try it. So 2x squared plus 3x plus 9 is equal to 1, or 2x squared plus 3x plus 8 is equal to 0. Now I'm going to use the quadratic formula. So x12 is equal to negative 3 plus minus the square root of 3 squared, which is 9, minus 4 times 2, which is negative 8 times 8, minus 64 over 4. Now notice that the discriminant, or this value right here, is negative value, and since we're only working with real numbers here, we won't compute this, we won't go into the complex world. So you can just put it down as x12 does not belong to R. In other words, x12 are not real numbers. The other possible case is that t minus 6 is equal to 0, or in other words, t is equal to 6, or the square root of 2x squared plus 3x plus 9 is equal to 6. And we can square both sides now. So 2x squared plus 3x plus 9 is equal to 36. So 2x squared plus 3x plus 9 minus 36, which is just negative 27, is equal to 0. Or in other words, I'm just going to put it down as x34, since we already had x12 is equal to negative 3 plus or minus 3 squared, which is 9, minus 4 times 2 times negative 27, which will give us a value of positive 216 over 2a, which is 4. And this is equal to minus 3 plus minus the square root of 225 over 4, or x34, the square root of 225 is 15, is equal to minus 3 plus or minus 15 over 4. So from here we have that x3 is equal minus 3 minus 15, which is negative 18 over 4, which is negative 9 over 2, and x4 is equal to minus 3 plus 15, which is 12, over 4, which is simply 3. Now, of course, both of these solutions are real solutions. And of course, we can try them out by plugging them into our original equation. Okay. So, our original equation is 2x squared plus 3x minus 5 times the square root of 2x squared plus 3x plus 9 is equal to -3. So when we plug in x3 or minus 9 over 2, we'll get 2 times 81 over 4 minus 27 over 2 minus 5 times the square root of 2 times 81, which is going to be 81 over 2, right? Plus, minus 27 over 2 plus 9 is supposedly equal to -3. Now, when we put in these values, 81, I'm just going to look at this part here first. 81 minus 27 is 54 divided by 2 is 27 plus 9 is equal to 36. So 81 over 2 minus 27 over 2 minus 5 times the square root of 36 is equal to 81 minus 27 divided by 2. 27 minus 5 times the square root of 36 is just 6, which is 27 minus 30, which is equal to -3. So our first solution is correct. When we try it out for our second solution, 3 to the second power for x4, which is 3. 3 to the second power is 9, times 2 is 18, plus 3 times 3 gives us 27, minus 5 times the square root of 2 times 9, which is 18, plus 9 is equal to 27 minus 5 times the square root of 36, which is 27 minus 5 times 6, 27 minus 30, which is equal to -3. So, in conclusion, these are our final answers to this equation. Thanks for watching. I'll see you in the next video, and if you enjoyed, make sure to subscribe.